Good evening, and welcome to the Moreau Lake State Park Astronomy Program, in conjunction with Adirondack Skywatchers. Today, we'll take a closer look at our nearest neighbor, our own moon. Now, close is a matter of perspective, and by astronomical scales, the 250,000 miles to the moon is a brief stroll. So let's begin our journey. Our moon appears as one of the largest celestial objects directly viewable with the naked eye from the surface of the Earth, and, other than our Sun, the brightest. With a diameter of 2,159 miles, it is about a quarter of the width of the Earth. This is extraordinary. We know of no other planet whose moon is proportionally that large. Most moons are less than 1% the diameter of their parent planets. The moon, or Luna, dominates our night skies and is often visible during daylight hours. Why does it shine so brightly? Well, it's not because the surface is reflective. The lunar surface has an albedo, or index of reflectivity, of about 0.12, meaning 12% of the sun's light that strikes it reflects back into space for us to see. This is similar to asphalt, and well below the 0.37 of our planet Earth itself. One of Saturn's moons has an albedo of 0.99, the highest in the solar system, reflecting almost all of the light that strikes it. This is because it's made largely of ice. Instead, the moon is so bright in our night sky because it is large and it is near. Luna is much more than an attractive nightlight. It reaches out to the surface of our planet, and we feel its effects in the form of tides. If it wasn't for these tides, life itself, including you and I, may not have formed on Earth. These tides stir up the contents of our oceans, help keep the water oxygenated, and form shallow tidal pools where water can warm and be exposed to solar radiation, thus accelerating many chemical reactions. NASA believes that a large moon may be required for life to form, and thus uses the presence of such a moon to focus their search for extraterrestrial life. Where did the moon come from? Well, the early solar system was not the well-ordered neighborhood we see today. Instead, it was filled with dozens or hundreds of smaller protoplanets. These early bodies, composed of rocks and ices, careened around the sun much like billiard balls careening around a pool table after a break. Our moon formed about 4.5 billion years ago, the result of a glancing collision between Earth and a Mars-sized sibling. A great cloud of molten material was shot skyward from the Earth's surface and formed an early ring around our planet. Over time, the material clumped together, forming the moon as we see it today. We know this because analysis of the moon's rocks show a similar makeup to the Earth's surface. In its infancy, the moon was much closer, perhaps only 14,000 miles from the Earth's surface. It would have dominated the night sky, and the tides it spawned may have been up to a mile high, washing over most of the surface of this early Earth. Its tides have also caused the moon to be tidally locked to Earth, always showing the same face to our planet. The moon continues to move away from us at the rate of about 1 3/4 inches per year. The moon appears to go through phases throughout the month, as its location relative to the Earth and the Sun change. When the moon lies between the Earth and the Sun, only a portion of it is lit. A new moon occurs when the moon is almost directly on a line between the Sun and the Earth, and so we are seeing the side of the moon facing away from the sun, and so unlit by its rays. A full moon occurs when the Earth is between the sun and the moon, and the rays of the sun illuminate the entire face that we can see. A lunar eclipse occurs when the moon is near a full moon in its position, and its orbit takes it directly through the shadow of the Earth. Since the moon is smaller than the shadow the Earth casts, only the sun's light rays that bend around the surface of the Earth strike it, similar to the red rays of the sun at first morning and late evening, when the sun's disk has yet to rise or already set. This causes the moon to appear anywhere from a dark gray to burgundy or a dusky reddish orange, depending on how close to the center of the Earth's shadow the moon is passing. We hope you've enjoyed this brief video. Please take part in our various astronomy program activities, including full moon lunar viewing during our full moon hikes, new moon planetary and deep sky viewing, and our eclipse and meteor shower events. Till then, clear skies to all.